What we are going to try to do is to draw a map of what we think is cancer. Not everything is completely secure as far as science. Some data, we just got them the day before yesterday, and I'm going to tell you when things are quite new and needed to be checked. So we come from the world of physics, and we try to understand cancer through the eye of physics. So a few points. First, inflammation, which causes cancer, is increased osmotic pressure. So you have a disease which is clinical, which has a physical explanation. Increased pressure causes cancer by causing the Warburg effect. That needs to be proven, but that appears to be correct on the first data. The Warburg effect is cancer, and cancer can be summarized to the Warburg effect. And accordingly, the treatment of cancer is the treatment of the Warburg effect. So the first point, inflammation and increased pressure are synonymous. As you know, inflammation causes cancer, Alzheimer's disease, Parkinson, and a lot of other diseases. Here we measure the pressure in inflammation, and you see that, can I have a pointer, or we don't have pointers? You see that you have increased osmotic pressure in every single inflammation. And second point, you can induce the secretion of all the pro-inflammatory cytokine by pressure. And the third point, which is the proof, is you take a disease caused by an inflammatory substance that is DSS, which is a dextran sulfate sodium. If the poor mice drink that, they will get inflammation of the stomach. Nobody knows how this chemical works and how it is toxic. What you can see is that when you have inflammation of the guts, you have you have changes of the architecture, disappearance of the crypts, and inflammation. The point I want to make is that if you take that substance and if you measure its osmolarity and you give it to mice, if it's above the normal osmolarity, which is 300, you see nothing. Below, you see nothing. Above, it's toxic, meaning that dextran sulfate sodium is toxic because of its molarity it induces. The point may be a bit technical, but it's important to understand that a disease which has so many different causes like inflammation can be summarized to increased pressure. And if you look at macrophages, you have the half-life of these cells, which is increased by osmotic pressure. The reason I talk about inflammation is because it's very important in cancer care, and we're not too far from immunotherapy. The second point is that life is a rather simple phenomena. Either you're dealing with anabolism, which has a lot of synonyms, including fermentation that Thomas used a few times, and catabolism. Cells can do either one or the other one. They cannot do both. And it's rather simple if you want to look at it. Either the mitochondria is on, it's working, so you have ATP formation, or the mitochondria is off and you have biomass formation. So if you have ATP formation, most of the energy goes into gradients. So you have either in the first time you make ATP, you make electromagnetic field, or when your mitochondria is off, you make biomass, you make pressure. So you have a binary alphabet. Either you make electromagnetic fields or you make pressure. So we tried now to see if we can induce the Warburg effect with pressure. I'm just going to show you one slide. It's data I got from Frédéric Bouillot from Cochin 2 days ago. But if you put the cells, and these are regular CHO cells, and if you put them on mannitol, so if you increase pressure, you will see that the cell respiration goes down. That's one of the two hallmark of the Warburg effect. The second, I'm not going to show you the slide in order to be shorter, but you have an increase in glucose uptake. So the Warburg effect appears to be caused, at least in this model, by increased pressure. So cells, that's a normal cellular metabolism. Glucose goes to acetyl-CoA, and we all know how it works. When you have increased pressure, we have data at this point supporting that glucose goes to acetyl-CoA. We have not measured lactate, but probably it's increased. And we have data supporting that, from another group, glutaminolysis is increased. So just to make the link between this talk and Thomas Seyfried talk, all the hallmark of cancer appear to be caused by the Warburg effect. Obviously, cell proliferation, metastasis is because of increased pressure, metabolic rewiring, but also the immune response. The activation of the immune system appears to be a consequence of increased pressure. So it is possible, and you hear I say possible, I'm not saying sure, that all the hallmark of cancer are a consequence of increased pressure and the Warburg effect. So what's the treatment? That's a slide which is similar to yours. We know, and it's been published a few times, that if you put back into cancer cells mitochondria, they turn out to be normal. But it's quite difficult to do on a human being. We don't have the machine to put mitochondria back in. So we need other tools to be able to be successful. One of the tools we have to normalize the metabolism is obviously chemotherapy. And we do PET scan to know if chemo is effective. So chemotherapy, and we'll go into that afterwards, is very effective at rewiring the cancer. But obviously, there are better things than chemotherapy, which has its own limitation, and we will not go into that. We can have found two ways of restarting the mitochondria. The first is targeting the Krebs cycle. And the second, and that's the first time I'm going to talk about that, it's a work I did with Jean-Jacques and my friend who is sitting there. It's playing with the pH. So that cost us 20,000 mice in order to find a combination which was able to restart the mitochondria. These are lists. These are unreadable, I know, but just to give you an example of what we looked after. We used mice. I don't like petri dishes, which are quite different from human beings. Mice are closer to human beings. And we did look at ways of improving the survival of these poor animals. This work was done by Ramin in the Pasteur Institute. And what we got repeatedly was that a combination of drugs I had never heard of before, called lipoic acid and hydroxycitrate, would improve the survival of these mice. These are data on bladder cancer. We'd have similar data on melanoma and similar data on lung cancer. In every single time, restarting the mitochondria would decrease tumor speed or tumor growth and prolong survival. These data were done by our group and confirmed later. So basically what we're doing is, this is the cancer metabolism, which, you know, we think is probably caused by increased pressure. The mitochondria is not working. You have excretion of citrate and you have lactate here. What these drugs do, lipoic acid opens up the mitochondria. As it opens up the mitochondria, the cell can breathe again, and the hydroxycitrate decrease the exit of citrate. We think, but we have not measured that it decreases the input of glutamine. That's not something we do know, but it's a real possibility. So at this stage, from our group and then confirmed by other group, there are multiple evidence that restarting the mitochondria with lipoic acid and hydroxycitrate improve tumor response, either spontaneously or in combination with chemotherapy. As you can read, there are more than 300 papers which confirm the efficacy of lipoic acid, and a few papers, with some from your group, which shows an efficacy in tumor cells. There are several trials of drugs in phase 1, phase 2 trials. Just to say that we are on the verge of a combination of either simple treatment and an expensive treatment. At the same time, the pharma industry is also trying to develop new drugs. So I'm not going to talk too much about the patient. There's just a couple of cases. Lady which was treated in a different cancer center, sent back home to die in 3 years ago, now working, and that's a CT scan or MRI. You can see she had 12 or 13 brain mets, and she's doing fine. So there are several cases like that of patients. They are all on ketogenic diet. I don't have to tell them, they do it by themselves. Ketogenic diet that we have no way of controlling how well done that is. They are on lipoic acid, hydroxycitrate, plus conventional treatment. These people are all on conventional treatment. And you can see these multiple brain mets. These are PSA of prostate cancer dropping after introduction of metabolic treatment in conjunction of standard treatment. So this is a paper I published close to a year ago. We have dramatic results in glioblastoma. We have dramatic results in brain mets. These and in patients with early stage 4 lung cancer and pancreatic cancer, but early in their history. Unfortunately, we don't cure people. These people are here, but they are not cured, and 3 out of the 8 glioblastoma patients have relapsed since publication of this paper. But clearly, the speed of disease is completely changed. Okay, now I'm going to tell something I have not said before. So you remember how mitochondria functions? Mitochondria produce CO2. CO2 plus water, it's an acid. So if the mitochondria is off, the tumor cells is alkaline. The fact that the tumor cells is alkaline has been published way back, but it's a forgotten fact. People are always speaking of the acidity, which is outside the cells, but inside the cell is alkaline. And it's what we use when we go to tumor boards or things like that. When they do the staining, the eosine hematoxylin, these are stains which stain the pH. They are pH-dependent stain. And the cells, the tumor cells, are basic. So, you know, I don't control everything in my life, and I think for other people it's the same. So somebody called me about 6 months ago, called Norbert. I had never met him, And he told me he had stage 4 pancreatic cancer, and he had taken the lipoic acid and hydroxy citrate, the ketogenic diet, and he had taken hypochlorite. I had never heard of hypochlorite, but his pancreatic cancer a year after was stable. He had not taken chemo. So when you hear that, you never know if you're dealing with somebody who is nuts or something which is real. So I did ask him to show up, and he came to a meeting we had at aux Arts et Métiers in Paris, and the guy was reasonable. Then I had the chance of a friend of mine who tried to explain to me hypochlorite. Hypochlorite is something which is known in the immunotherapy or immune system. It's how the granulocytes eat the cells. They secrete hypochlorite, and that's the way they digest cells. So I'm going back to the chemistry of chloride ions. So it's a bit complex. I'm not going to get you lost, and I'm not completely on firm grounds. But hypochlorite and chlorite were synthesized by Berthollet, and we're back at the French Revolution, so it's way back. In 1818, Louis XVIII was dead, and he stunk, and they did not know what to do, and Labarack, who you had not heard of, neither did I, used hypochlorite or chlorite just for on the face of Louis XVIII for it not to smell too much. And when Semmelweis, so we're now going to Vienna in the 1840, wanted the students to stop killing the ladies, he asked them to wash their hands with chloride or hypochlorite. And that's the basis for the Daquin solution. If you go to the chemistry of the chlorine ions, we all know salt, but you also have different ions, more or less oxidized. And you have salt, which is radioactive, you have chlorine, you have hypochlorite, and you have perchlorate. Perchlorate is, if you want to make a bomb, it's what you need. And that's what Lavoisier worked on. Anyway, this is hypochlorite. Hypochlorite is what the neutrophil use to kill cells. And this is the PSA of a patient who was there when Norbert came with his advanced pancreatic cancer. This man, advanced prostate cancer, unresponsive to hormones, cord compression at the beginning, and for the specialist, Gleason grade 8 out of 9 or 10. And his PSA dropped dramatically when he started using hypochlorite. Hypochlorite, and just here a peak, which decreased when he increased the dose. One point which appears to be important, as you're dealing with free radicals, which have a very short half-life, this man is taking the hypochlorite every other and a half, because it's a very short half-life. We think he has to take it at night also, because apparently cancer grows at night. And for the one who have been on cancer wards, the people complain mostly at night. I don't know if it's something which is known or not, but apparently cancer grows mostly at night. The way we try to understand what we see with hypochlorite, it's an extremely simple molecule. You can see chlor, hydrogen, and oxygen. You cannot get smaller as a medication. It goes everywhere. The way we understand it, or we think we understand it, is that when it gets into the cell, it's a weak acid, which pKa is 7.5. In the alkaline environment of a cancer cell, it's activated and gives you dioxide de chlor. I'm sorry for the English. and destroys the cells. So these are experiments. I got the results also 2 days ago. First, on red, you see normal cells. The pH is 7.2. So it's known that below a pH of 7.2, cells cannot divide. When you look at cancer cells, the pH is alkaline. And when you add either metablock called, so it's lipoic acid and hydroxycitrate, or with hypochlorite, you don't see much. When you do a combination of both, you decrease the pH. And when the pH goes below 7.2, the cell cannot divide. The same with the mitochondrial potential. If you use either the metablock, so the combination of metabolic treatment that we discovered, or hypochlorite, you increase the mitochondrial transmembrane potential. These are the points I want to make. First, cancer is the Warburg effect, and that's what we face. It's a clear definition of the disease. Until proven otherwise, it appears to us that it's as simple as that, until proven otherwise. Cancer is caused, or is mostly caused, by increased pressure which turns off the mitochondria and the cardiolipin of Professor Seyfried. The increased pressure caused a decrease in mitochondrial activity, probably caused by inflammation. For the one who loves physics, it's not too far from Newton's third law. And treatment should aim at restarting the mitochondria. The drugs available are multiple. You can use DON, you can use lipoic acid, hydroxycitrate, hypochlorite. You have multiple treatment options. It's obvious that for the patient and for everybody, clinical trials are needed urgently. Thank you very much.